Welcome back. This is tutorial 8, confidence intervals 2. Before we start, as usual, let's go through a little bit of admin. So your CML3, the second attempt is open now, but it will be open only until tomorrow, Friday, 4 p.m. So make sure you have a go at your second attempt. Most of the students who try a second attempt, they increase their grades. So I think it's always a good idea and also good practice before your LBRT 2, right? Also, the first attempt of CML4 is open and will be open until next Monday, 4 p.m. too. Once again, it's a reminder that we always give CMLs. You need to submit at a certain point. Don't forget to submit it. Otherwise, you're going to get a 0. If you save and close without submitting, it doesn't work. Okay. Now, something very interesting. Dominic prepared a graph with the distribution of the grades from our cohort. You will see there are 131 students that did at least one of the attempts of LBRT1, and there is a median 20 and mean 19. So the average and the median are a little bit different, right? As we've learned before. And this summary here and these numbers, they are excluding 0. I wanted to call your attention for the next slide that I prepared. Have a look at it. So all students, and here I haven't excluded 0. This is how we did. And for the people in our tutorial, 48 students did at least one of the attempts. And look, we did a little bit better than the average. So it looks pretty much the same here, but you can see quite a lot of people did a very good score and not so many people in here. But the most important thing I wanted to show you and to share with you is that students who attended all the tutorials until last week or missed just one, look how well they did. They mostly in this area here. And look at the mean and median of their grades. So congratulations, there were 17 students in that situation. But so important thing, although we cannot say there is a causation relationship here, at least there is a correlation relationship. So it doesn't mean that because they attended 5 or 6 tutorial, they did better. We don't have enough evidence to say that, but at least there's some correlation. Students who did that ended up also doing better. So I hope this motivates you guys to keep attending every tutorial and interacting and answering the polls, because the results, there are some results there that you can take as you will. Okay. And for the next one, you probably saw an email we sent today. Dominic sent, and we some emails for the IVAs are being sent. For our group, I've sent the emails for the people who will attend an IVA. So please check your student email, so your UQ email, and give us an answer. You have only 72 hours to let us know your availability. So I'm offering blocks between Monday and Wednesday on the 20. Let me check here, 23rd to 25th of January. So not next week, the other one. There are a few blocks that you can choose in between. And if by any chance, like it's impossible for you to attend one of the blocks, you let me know. We'll try to schedule on another way. You don't need to worry too much. This is not a cause of alarm. If you're invited to an IVA, we will do a 15-minute Zoom meeting. It will be recorded, and we will go together through some exercises to see how much your understanding of the course And if you're able to solve, even if you do a mistake or two, we will point the mistake and allow you to adjust, to correct, and it will follow on. So the idea here is to check if you know what's going on, or if you have no idea what's going on. Okay, and that's it about admin stuff. Any question before we start the tutorial? Let me open the chat. Oh yeah. Okay, if you do well in the course, are there opportunities to become a tutor in the future, and how would we contact someone to organize this? Yes, you Harry, there is. So it works a little bit like this. Usually people who get a 7 in the course, they are automatically invited for an interview, and this happens around October each year. And usually the person who will contact you, her name is Marie. Marie will send an email to everybody who got a 7. And if you're a first-year student, you'll probably be offered to join to become a PAS leader first, and then a tutor. But if by then you're at the end of your 2nd year already, maybe you can go straight to becoming a tutor. But it's a process that happens every end of semester, and every end of the year. And around October, end of October, beginning of November, she starts sending the emails. So yeah, if you guys guarantee a 7, there's a chance. Yeah, good luck with it. Yeah, no worries, my pleasure. Any other question? All right, so let's go. Tutorial 8, confidence intervals 2. So in this tutorial, we'll be playing a little bit with the functions we had. We'll also be introduced, most importantly, to error and how to look at our equations and identify what is the error. At the end of this tutorial, you should be able to determine the sample mean or level of confidence for a specified confidence interval, determine the sample size required to provide a specified level of confidence for a confidence interval, and calculate confidence intervals for the difference between 2 population means. That will be the last exercise. Okay, so let's go. As usual, first exercise, I probably have a poll, as you guys are used already. Let me launch the poll before I start reading the question with you. Question 141. It's launched. So it costs more to produce defective items, since they must be scrapped and reworked, than it does to produce non-defective items. This implies that manufacturers should ensure the quality of their products by perfecting their production processes, rather than through inspections or inspection of finished products. All right, so it's better to do it right in the first attempt than to keep checking and trying to rework. So let's start the exercise now. In order to better understand a particular metal stamping process, a manufacturer wishes to estimate the mean length of items produced by the process during the past 24 hours. So the mean length, how long it is, right? In average. So A, how many parts should be sampled to estimate the population mean length within 0.1 millimeters with 90% confidence? Previous studies have indicated the main standard deviation is 2 millimeters. So let me have a look at the poll. We have 10 answers up to now, 11. So, well, I will give you another 30 seconds, 12 answers, 14, another 30 seconds. So what is new here? I'm asking about which symbol we give to 90% confidence, which symbol we give to 2 millimeters, And what is really new, sorry, is the 0.1 millimeter. We say how many parts should be sampled to estimate the population mean length within 0.1 millimeter. I have 16 answers, and I'll end the poll missing 5 people. 3, 2, 1, go. All right, I ended the poll, sharing the results. So let's go. Look at what we have here. I think by now you guys are already used to the confidence. I tend to give a little bit of advice there. So 90% confidence is the level of confidence, right? Previous studies have indicated that standard deviation is 2 millimeters. So not a sample, not our sample, not the numbers we have in hand. Previous studies before. So this is talking about population. So it is sigma. And finally, the 1 millimeter, 0.1 millimeter is what we're talking. It's the error. And you will notice, because we say we want to estimate a population mean length within 0.1 millimeter. Let me check how we did. So for the first one, 9 out of 16 got it right. So good job. For the second one, 8 out of 16 got it right. That's very good. Very good. Good job, guys. And what symbol? This is new, and I understand 4 out of 16 got it right. It's quite distributed, but it's the first time you guys are seeing the error. The advice here, look at the within. It's one of the words, or you will see it's talking about, I want the error to be somewhere in a range, okay? I'll stop sharing. Let's go to the next one as you're used. I know if you guys feel like it's a little bit repetitive, I understand. I just want to make sure you guys are like, when it comes to CML, in particularly LBRT, there's no mistake. You get it right away. I don't think you guys need a lot of time for this one. It's just 3, the one that we've been doing since ever. I have just one answer up to now. But this poll is about what type of problem are we talking about? What table will we use based on your answer here? We know the table and or the distribution. And what is the value for alpha? Okay, I have 8 answers already, another 15 seconds. I still 9 answers out of 21. We can do better. We can have a lot more than that. 12 answers. Let's go. 5 seconds. A little bit more, guys. 13, 14. All right. I will end the poll. 16. Amazing. Let me share the results. And so here we're estimating the population mean. So we're trying to estimate mu. So it could be, so at first we eliminate our freaky fish, right? And we know we're talking about a sample. So how many parts should be sampled? So you eliminate the seagull. And finally, we know sigma. We're not talking about a sample standard deviation. We're talking about a population standard deviation, because previous studies have indicated the standard deviation is 2 millimeters. Okay, so pelican. Given it's a pelican, it will be, let me see here, 7 out of 16 got it right. Congratulations, guys. Good job. The other one, what table will we use? That because it's a pelican. Fantastic. 11 out of 16 got it right. Very good. Good job. And finally, calculating the alpha, 10 out of 16 got it right. Since we're talking about 90% confidence, our alpha is 1 minus the 0.9, and it's 0.1. You guys are killing it. Good job. Let's stop. And let's continue. So now, what do we have? Let's put a lot of things in the screen here. I don't know if my camera, my things are covering what you guys can see. Let me put it small. So what information do we have? We had a sigma that we talked about, 2 millimeters. We had a level of confidence, 90%, that they say here. And with the level of confidence, we can calculate our alpha. And we have an error, 0.1 millimeters. And what the question is asking us, how many parts should be sampled to estimate the population mean? So it's the sample size, right? They are asking us what is n. We're going to calculate. So since we know the level of confidence and we know we're using a Z table, we can already fill a little bit the data in here. The same way we did last week. So 0.9, 0.45 is half of it. And we know that this little corner here is 0.05, right? And what is Z crit? Because what we're going to use is this equation here. Look, when we're talking about an error, look at let's have a look at our confidence interval. Oh, my computer froze a little bit, so it'd be ugly. Okay. This is how we calculate the interval. This is our point estimate. So our average is 2. It's a point in that. And this is the error we put. This little part after the plus and minus is what we call the error. So E is equals, in this case, for the Pelican, E is equals Z crit times our standard error, which I'll go through it, but our standard error is the population standard deviation divided by the square of the sample size. If you rearrange this guy, you end up with this. So you're basically passing n to the other side, but because it's a square, you take the square root from here, you put the other side squared, and E is passing to the other side in the denominator, right? It's multiplying up here, so we'll be dividing in here. So it's the same equation, once again, but rearranged. So we isolate n here to calculate, and we need to calculate this thing here. We know E, where is it? It's here. We know sigma, that is here. The only thing missing for us now is Z grid. But lucky for us, we know the level of confidence, so we can do what we've been doing and for a while now. We can look for the Z grid in the table, the Z table, to be more specific. So let's go. Please, on chat, can you guys give me the value of the Z grid based on this area I have here, 0.45? So you have a look, actually. Xiao Han is the one who said the right thing. And I'm trying to color code for everybody. Look, where usually, and I will try, usually when we're looking at the number that is here, you will have it in purple. But yeah, exactly. Did I ask the wrong? Maybe I asked the wrong thing. But now we have the area. So I'm painting it in red, 0.45. And we want to find this number here, right? Let me go back, like second attempt, maybe. Let's go there. So we have the area. Yeah. Can I get you guys to try it again, but the other way around? So we have the area, and then you find the numbers. Nice. Amazing, guys. Thank you. Good job. So I don't need to cross it for you. Basically, we're doing what we did before. The 0.45 sits right in the middle here. Therefore, we get the values for these two guys. The line is 1.6 and the other one's It was 6.4 and 6.5. Half of it is 1.645. Good job. Thank you for interacting with in this one. Let's go. So we have Z, 1.645. So how do we continue our exercise? Let's go. So I'm getting this formula here, and then we can replace all the values in there. So 1.645 is our Z, our sigma is just 2. We're talking about millimeters in here, and 0.1. Important thing, pay attention that these guy and these guys, they are in the same unit. And this is pretty important here because we're dividing one by the other. So if this was talking in meters and this was millimeters, you would find something wrong. So pay attention. It's important to have it in the same units, using the same units. So millimeters divide millimeters, they disappear. Then you have 182.41 parts. I thought, did I was supposed to leave, okay, I put it right, like directly there. I put that it's rounding up. And why is that so? Anyone want to give it a go to see why we're rounding the amount we found? Exactly. We do always round up, and exactly. Excellent. Thank you so much. That's very right. So we always round up when we're looking about the size of the sample, because you can't produce 0.41 parts unless, I don't know, maybe producing parts a bit easier to do like a fraction, but you can't interview half a person. I think it would be very difficult, I imagine, unless you have superpowers. But we usually, when we're looking for sample size, we try to, if you have a broken number, something with decimals, you round up, because the more people you do, slightly smaller the error is. If you round it down, therefore your error will pass the limits. So thank you, Zhenshon and Harry, for answering this one. You guys are right. Okay. Let me go. So just writing it down. Therefore, at least 1,083 parts should be sampled. That's the writing down the answer. And that's it. Question part B. So time permits the use of sample size no larger than 100. The sample size can't be 1,083 parts. It's just 100. If a 90% confidence interval for mu is constructed using n equals 100, will it be wider or narrower than would have been obtained using a sample size in A? Explain. So we have a smaller sample. Let's put a few things here. Now we know n. The thing here, what changes? So we know n, we know z crit, 90%. So it's still the same. So it doesn't change. Sigma, there is a historical, where is it? Previous studies have indicated that standard deviation is 2 millimeters. So historical thing, it doesn't change. No, they're not giving any new value for us. So what is changing here, what's missing is the E. We'll have to calculate E to understand what's going on. For this exercise, in particular, we don't need to calculate. We will calculate here in the tutorial, but you could just have guessed what you looking at the formula, what's going on. But I think it will be important to get, yes, yeah, good job. It's important to start getting a feeling, and calculating will give some more visual of what's going on. So now that we don't know E, we can choose another formula, the one that isolates E to the left, right? And Z crit times sigma divided by the square of n. And look how it goes. 1.645 times 2 divided by the square of 10, square of 10 of 100, square of 100 is 10, and we get 0.329 millimeters. And then try to picture it. If our error, remember what we call error is this little guy here. So if these guys, oh, I gave the answer already. I'm sorry. I should have broken it into 2 steps. If this guy is a little bit larger than the previous guy we had, which was 0.1 millimeters, do you think our confidence interval will be wider or short, or narrower or smaller, right? And by adding and subtracting more from the point estimate, by getting a bigger error here and a bigger error here, you can see that clearly our confidence interval will be wider. So if a 90% confidence interval formula is constructed, will it be wider or narrower? It will be wider. Okay. Let me click. If you guys have any questions, feel free to open your mic or to send a message on chat. But yeah, essentially, you're right. It's wider. So I thought I clicked. Okay, the confidence interval will be wider since allowance for sampling error on either side of the mean will be bigger. So the error E will be bigger in either side. Okay, so next one, let's go to the next one. If management requires that mu be estimated to within 0.1 millimeters, so error is still 0.1, and that a sample size of no more than 100 be used. So sample size 100 and equals 100. What is the maximum confidence interval that could be obtained for a confidence interval that meets management's specification? Note that previous studies have indicated the standard deviation is 2 millimeters, right? So we're still talking about 2 millimeters. We still have n equals to 100, and we have E equals to 0.1. Let me click once. These are the information we have: sigma 2 and 100 E. So what we don't have now is the level of confidence. So I think I want to emphasize how many times that we're still working with the same equations. It's just we're taking one variable and put in another one and try to calculate what we should do, right? So let me click. What is the level of confidence? I'll put the same equation there. Did I put the same equation? No, I didn't. I actually rearranged the equation, sorry. So what I did, can you see that E is equals to Z crit times sigma divided by square of n? So I sent this guy, let me use this one. I sent this guy to the other side. But remember, when it goes to the other side, it goes, instead of multiplying, it's dividing, right? So if it's dividing, it's the same as flipping it around and multiplying. I hope that makes sense in the algebra for you. So Z crit is equals to E, the square of n came up, multiplying with n, and sigma came down, dividing. So sigma is down, square of n is up. Okay, denominator and numerator. All right. Then Z crit, we click, we have 0.1 times the square of 100 divided by 2, which is 0.5. Okay, so now I know Z crit, its Z value is 0.5. What are we looking for in our Z table? I think that gives a little bit of a hint. 0.5 is down here, so it's the line. And we are looking for what is in red, okay, the area. Let's go. Can you please get me on chat the value we find for 0.5? Amazing. Good job, guys. Very good. Very good. Thank you. Let me click here. Basically, 0.5 is pretty easy because the last decimal is 0. So just this guy here. Good job. So now we know 0.1915. It's the area of what? Is it this area? Can someone put me on chat? What area are we talking about? I would be happy just with the first one. I think it's important to discuss it. Just exactly, she won. Thank you. So let's go back here. And this is an advice that our tables give you. Oh, where is it? Annotate. Always have a look here. It's just the distance from the mean to one side. So in this case, we're looking that 0.195 will be just one side, right? And since we have plus and minus in our confidence interval and z-grid, that's how we do this exercise. Look, it will be 0.1915 and 0.1905. So the probability of z being between minus 0.5 and 0.5 is equals to the addition of both areas, which is equals to 0.383. So 38.3% level of confidence. So therefore, the answer here, therefore, the maximum confidence interval is only 38.3% when n is equals to 100 and error is within 0.1 millimeters, which means if you try to restrict the size of the sample, you want a small sample, but you still want a small error, your confidence interval won't be really a confidence interval, really high. Okay, so shrinking everything, trying to shrink in everything, something will be bad, will suffer. In this case, was the confidence interval. Okay, so that's it for question 1. Do you guys have any? If you have any question, yeah, feel free to chat. Let me check the chat or open your mic. Otherwise, we're moving to question 2. Let me close this. There will be a poll if I know myself. Let's go. Question 2, launch. So you have your poll there. That will be 5 questions, a little bit more, but still same style as usual. So you wish to estimate the mean of a particular population, and at the 95% level of confidence, you want your sampling error to be no more than 50 grams. You take a sample of 100 from the population, and this gives a sample mean of 5,000 grams and a standard deviation of 800 grams. And then question A, on the basis of the sample, construct an interval estimate of the population mean. Let's see how the poll is going. I have only 3 answers up to now. 4, 5. There are 5 questions. I know it takes a little bit longer because we have a few things. So start with the easiest one. We have a 95 level of confidence. Then we have a 50 grams. Then we have a sample of 100. Then we have should give to the value 5,000 grams, and then we have 800 grams. Right, I have 11 answers out of 22, just half of the people, 12 now, 13. I will give you another 30 seconds. So let's read it again. You wish to estimate the mean of a particular population, and at the 95% level of confidence, you want your sampling error to be no more than 50 grams. You take a sample of 100 from the population, and this gives a sample mean of 5,000 grams and a standard deviation of 800 grams. Guys, I have 15 answers. I'm sure the last 5 seconds, 16, 17. I'm missing just 5 people. Let's go. 3, 2, 1, and nice. 18 answers. Good job, guys. Let me share the results with you. So let's discuss it. First, 95 level of confidence. 14 out of 18 of you guys got it right. You're killing it. Good job. Second question. What symbol would you give the value 50 grams? So we're talking about you want your sampling error to be no more than 50 grams. So it's the E, the error, or sampling error. And 6 out of 18 of you got it right. I can see quite a distribution, but I know it's a new concept for this tutorial. So, good job. If you didn't get it right, that's what we do here, the exercise, right? So what symbol would you give to the sample of 100? It's N. It's the size of the sample. 14 out of 18 of you got it right. Amazing job. What symbol would you give to the value of 5,000 grams? I can see X bar was 11 out of 18. Excellent. Because it's coming out of the sample mean, right? So you take a sample of 100, and from the population, this gives a sample mean of that 5,000 grams. And finally, a standard deviation of 800. It's little s, which 7 of you got right, 8 said sigma. And the trick here is that both the sample mean and the standard deviation are coming from the sample. That's the tricky. It's not saying the sample standard deviation, but it comes in this phrase where it's talking about the sample, and it comes right after the sample. We say this and this, right? So that's the tip for this one. I'll stop sharing because we have another one. Good job, guys. To a launch, as you're probably expecting already. So you wish to estimate the mean of I have read this before. I will give you just a minute for this one. So basically, what type of problem is it? What table will we use based on the type of problem? And what is the value of alpha? Just 3 questions. I have 4 answers now. I think 5. You guys know how to do this one pretty well. 8. Another 25 seconds. There is a little difference, right? You probably noticed between this exercise and the previous one. Let's see. Five seconds. 2. All right, 19 answers. Great. Out of 23. I'll end the poll and share the results. So the only difference we have is that these exercises, instead of having sigma, we have the sample standard deviation. So we have S. That's why instead of being a pelican, it's a shag. But we're still talking about a sample, so it can't be the seagull. And we're not talking about proportion. We're talking about mean, so it can't be the freaky fish. All right? So 11 out of 19 of you got it right. Therefore, 9 of you got it right out of 19. It's the t-table. Every time we have a shag, we use the t-distribution, student t. So it's the t-table. And finally, the alpha. 13 out of 19 of you got it right, because we're talking about a 95% confidence interval. Excellent level of confidence. Okay, I'll stop sharing. Good job, guys. Let me close. So let's go. Let's solve the exercise. So on the basis of the sample, construct an interval estimate for the population mean. We have the error, the n, x bar. This is the information that we already identified in our post. I put here some simple things. It will be a t distribution. So if we know the level of confidence is 95%, let's see, this is how it plots down to there. We also, from the level of confidence, can take a few more things. One of them you guys did by yourself, which is the alpha. What else? We also have, this is one alpha divided by 2 is used as one of the parameters for our t distribution. So you will see that we have alpha divided by 2, 0.025, which is this little area here. And the other parameter for our t distribution is the degrees of freedom that we discussed 2 days ago. And it comes on n minus 1, so 100 minus 1, 99, right? So we're going to look for this guy here in our t table. Look at that. I will open my chat to see if you guys can find. And I'm not sure if I emphasized the difference we have between the Z table and the T table. When you attempt for the first time, you notice that it's different. And how different is it? Look, at the T table, we're looking, instead of the distance between the mean and, instead of the area between the mean and our T crit, we actually use the area. So instead of the area being in here, let me use this guy. Instead of the area being in this area, oops, sorry, my computer froze a little bit. The area is in here. And we're looking at this little area. And here is the degrees of freedom. So the numbers that we're looking at are the T crit. So it's the numbers that we see in here. Yeah, Minken, I can see. Nice, good job. Let's see. Yep, Harry, good job. Yeah, some more people. Could you find it? So, excellent. We have T 0.025. T 0.025. They again, they take the 0 out of the thing, but it's in this column. And then degrees of freedom 99. We come from here and we end 1.984. Excellent. Thank you, Hausen. Thank you. There you go. So now we have it. We have the values here, 1984. Let me click again. As it's a shed, we will use this equation. So x bar plus or minus the t times the standard error for the sample equals you replace the values. And we find that mu, we're looking for the population mean. Mu is between 4,841 and 0.28. And 58.72. Let me see if there's a little bit of text. I didn't write a little bit of text for this one. Okay, so that's the answer. Okay, let's go. B. Does this estimate satisfy the requirements regarding the sampling error? So we want error to be no more than 50. Look at that. Look at here. So the error is this little part here, as I explained before. So let's calculate what is the error in this case. T times S divided by square of n, which gives us 158.72 error, and it's bigger than 50. So it doesn't satisfy the requirements regarding the sampling error. Okay. And finally, C. If the answer in B was no, which tends to be usually, what sample size would be required to satisfy the conditions of 95% level of confidence with a sampling error no more than 50 grams. Assume 800 grams is a good estimate of sigma. So let me click. Look what happened. There was a shag. There were the degrees of freedom. There were T distributions here. But look now. Look at it now. It became a pelican. Why so? Because we are using now sigma instead of S. So no T distribution anymore. Z crit instead of T crit. All right. And we're looking for our N. And we're looking for this thing here. This equation, the N. What is the sample size? Okay. Too fast. So it's still 95%. It's still the area is still 0.475. Not still, sorry, it changed. Did it change? No. Sorry, it's still from the same. Apologies for that. So still 0.475. And let's go. Can I please have now, you know, the area 0.475. Can I please have the Z crit? Excellent. Yes, excellent. Great job, Harry and Xiaohan. Let me click. You will see 196. Spoiler alert. This is, if you continue studying econometrics, this is the number you see most often. Okay, 95% level of confidence is the most common. So you see a lot of 1.96. But well, let's go. So sorry, we found 1.96. Put it in here, minus and plus. And we're going to use this equation, just as simple as replacing the values. 1.96 times 800 divided by 50 squared equals 983.45. Did we finish? Trick question. Have we finished? Okay, I just want a yes or no in the chat. Yeah, I think the intonation gives a little bit of advice, right? So we're looking for the sampling size. Yes, she won. Thank you. Good job. We need to round it. So we round it up. Yeah, good job. A sample of at least 984 is required to satisfy the condition. They don't say what is the population, but usually in sampling we don't take halves or fractions. We just take round integer number of. We also don't take negative. It's just integer numbers of observations. Okay, that's it for question 2. Feel free to send any question. Otherwise, more poll for you. Question 3, launch. It's probably going to be, I'll give you 1.5 minutes, maybe 2. Let's read it together. It's pretty short. It's just 3 questions this time. A market researcher wants to know what proportion of shoppers at a large appliance store make a high price purchase. So who spends a lot? To estimate this proportion within 0.1 and be 95% confident of the results, how large a sample should be taken? And I'm asking you just 3 things. I'm asking you what symbol we give to the 95% confidence, what symbol we give to the within 0.1, and what is our variable of interest? What are we trying to find? I have 5 answers out of 23. I'll give you another 30 seconds. So asking 3 things, The confidence, I think you guys already know how to do, right? But we have this to estimate this proportion within 0.1 and be 95% confident of the results. How large a sample should be taken? So what are we trying to find here? What is our variable of interest? I have 10 answers only. Seems like a more challenging one, this one. Give you another 5 seconds. 13 answers. 3, 2, 1. Oops, sorry. There we go. 14 answers. King 15. Excellent. Share results. So, let me also click here. 95 confidence is the level of confidence, as you guys know really well. 10 out of 15 of you got it right. 0.1 is the error that we're learning today. So just 4 of you got it right. But remember, the within is kind of an advice. Like, I want something within. I see that we got 5 people saying p hat, and this was very close to proportion. So tricky question. It makes sense to think this could be p hat, but it's not. It's just how far from p hat we want it to be, or from, in fact, from p. And finally, the size of our sample is what we're looking for. So how large a sample should be taken? So this is n, and 6 out of 15 of you got it right. Okay, let's go. Another one. Stop sharing. Back. Just 1 minute for this one. Is that okay? Exactly same question as per usual. Identify what type of problem we're talking about. Then based on it, let's see what table we use and what is the value of alpha. This one, you guys are already doing really well. Like, I think the repetition is what makes you guys like professionals at this one, right? I have 5 answers, another 30 seconds, 7 answers, 9. Very good. So what type of problem we have right now, and what table we use, and what is alpha? "17 answers, another 5 seconds. Missing 6 people. That's it. 18 answers, 19. So I'll share the results. In this case, as you notice, there is this keyword talking about proportion a few times. So we're talking about the freaky fish, my favorite character in this course. And freaky fish, or a population proportion, uses a Z table always, and the alpha is 0.05 because it's a 95% confidence interval. So 15 people out of 19 got the alpha correctly. Good job. The Z table, let's do one first. The proportion, just 4 out of 19 of you realized that this was a proportion exercise. So pay attention to the keyword, right? And finally, given it's a freaky fish, it's the Z table. 10 out of 19 of you got it right. Okay, we'll stop sharing. And let's go to the exercise. It's a relatively short exercise. So we have an error, 0.1. I left a grams there. There shouldn't be a grams there. But we have a 95% confident. And we know we are working with a Z table, so Z distribution, so Z crit. But we don't know the size of n. It's what we want to know. And we can also expand a little bit. So we have alpha that you guys calculated. We know Z crit. I didn't take you to the table because we just calculated the 1.96. So pretty much the same. When it's a Z table and it's talking about 95%, the Z crit is 1.96. But where's p hat? How do we know? How do we calculate if we don't have either p or p hat? Tricky. So in this situation, what we do is we assume p hat to be 0.5 because it gives us the biggest number for standard deviation, p hat 1 minus p. Therefore, we're going to towards the safe side. We are doing, okay, let's be careful and get a bigger sample size, which covers any distribution. And if you want to try it, 0.5 times 0.5, which is 1 minus 0.5, right? So 0.5 times 0.5 is 0.25. Any other combination will be equals or smaller, but like basically smaller if it's different. 0 times 1 minus 0 is 0 times 1, which is 0. 1 times 1 minus 1, which is 0, is also 0. And you can try a few others in between to find out. Okay, p is always between 0 and 1. So okay, since we don't have p hat, this allows us the safest or largest sample size for our specification, and this is the slide that talks about it in the lecture. So let's go. We're looking for, I kind of went through here in the equation assembly, but basically the slide already has it. Rearranging the numbers a little bit, you end up with this formula. N has to be bigger than z crit squared times p hat times 1 minus p hat divided by error squared. Okay, and replacing the values, we have this, and we find 96.04. Did we finish the exercise? What are we missing now? Is 96.04 the answer? I'm looking at the chat, waiting for your opinion. Nice. What is missing? Amazing. Which direction should we round? Yes, amazing, Harry. Thank you. Good job. So we're rounding up because we're talking about sample size. So we can't have 0.4 of the sharpest. It will be probably like a pinky. We're not interviewing like parts of people. So let's round it up. 97 people interviewed. And therefore, a sample of at least 97 should be taken. Okay, that will be the sample and the value of n for us. And let's go. Another thing, if the population proportion is believed to be no more than 0.3, what sample size is necessary? Look at what changed. Oh, I think I've made a little mistake here. Instead of p hat, let me scroll back. It becomes a p. I can see I didn't change for 0.3. I should have changed it. Now it's p and it's equals to 0.3. So let's apply the same formula. But now instead of p hat, it's just p. And we have 1.96 squared times 0.31 minus 0.7. I have a few mistakes here. This should also be 0.3 and it ends up being 0.7. I apologize, but we end up with 80.67, which we round up to 81. And in this case, a sample of at least 81 should be taken. Quite a few mistakes in this one. If you don't mind, apologies for that. I just fix. Can I fix? MC, yes, probably. Quick, I promise. So let's go. This should be 0.3, right? This is also 0.3 because 1 minus 0.3 becomes 0.7. And that's it. And what else? This one. Amazing. Thank you for your patience. That is it. All fixed now. Any question? Let's see, chat. Feel free to open. We're going to the last question if you don't have any questions. This last one, question 4, talks about, it's something new. We're comparing two means. and I will put our poll up, and we will do it together first, because this is I would say more challenging than the previous ones. Let's launch. And okay, let's read it together. A real estate agency wants to compare the appraised values of studio apartments in 2 regions. As you can see, it's Taringa and West End. The following results were obtained from random samples. So for Taringa, we had a sample size of 55. We had a mean of $191.33 thousand and a standard deviation of $32.6 thousand. And in West End, we had sample size of 44, mean of $172.34 thousand, and standard deviation of $16.92 thousand. Okay, so what symbols are we giving to those values? I can see we already have. I'll give you another 30 seconds. We have 13 answers out of 24 students. Very good. 15. You guys are considerably quicker with this one. Good job. So we're asking another 15 seconds. So what the symbol for 95%, for 55 and 44, for 191, 172, and for 32 and 16. Another 5 seconds. I have 19 answers, just missing 6 people. 1, go. Oh, and the poll, 19 answers. I'll share the results. So what we have here, so level 95 confidence is the level of confidence. 15 out of 19 of you got it right. What symbol for 55 and 44? Basically, say sample size. Let's see how many of you got it right. 12 out of 19, very good. 63% of you got it right. It's an N, size of the sample. Then 191.33 and 172.34. It's X bar. It's the mean standard. Sample mean. It just says mean, but it's the sample mean. Let's see. X bar. 9 out of 19 of you guys got it right. And finally, the standard deviation. Here, it's the sample standard deviation. So it's S. 10 out of 19 of you, more than half of you got right. Great. Good job, guys. Stop sharing. And let's go for the next one. Finally, that I have spoiled the answer. I apologize for that. But let's go. Just 1 minute for this one. What type of problem do we have? What table do we use? And what is the value of alpha for this first question here? Because it says setup of 95% confidence interval estimate of the difference between the population means in thousands of dollars. Okay, I have 6 answers. We have 25 people who could answer, 9 answers now. Another 25 seconds. 12 answers. I keep doing it, sorry. 13, 14, 15, very good. Another 10 seconds. 5 seconds. 3, 2, 1, that's it. Okay, 19 answers again, let me share. And yeah, I apologize for all the spoiler going on. So what's going on here? We have a shag. 11 out of 19 of you got it right. And why is that so? We have S, the sample standard deviation. We don't have sigma, the population standard deviation. That's why it's a shag. We're talking about sample, so it can't be the sigil, and we're talking about means. So it can't be the proportion guy, our freaky fish. Okay, given it's the shag, so we use a T distribution and a t-table. 12 out of 19 of you guys got right. Good job. And finally, calculating the alpha is 0.05 because of confidence intervals 95%. And 13 out of 19 of you guys got right. All right, I'll stop sharing. And it's actually, look at this one. When we are comparing to, when you're doing the difference of the means, we classify this problem a little bit differently. And you will see this symbol in your lectures, and I'll try to use it as much as possible in the tutorials. Salmon versus trout. So we have a sample here, we have a sample here, and we're comparing them. Okay, so the shad became the salmon versus trout. What's going on here? So to do a comparison of two means, so to find the difference between two population means, we need to follow 3 steps. And this first time I'll guide you through it. I won't be asking too many questions, but this is what we're doing. Step 1 is to find a pooled variance. I hope you guys have watched the videos from Call already, the ones we have on YouTube, and the lectures too, but at least the ones on YouTube, and have seen why and how we're doing all of this. It seems a little bit complicated, but the idea here is we're trying to have the same variance for both samples. So that's why it's pooled variance, like we pull everything together to get just one variance. Okay, and for the step 2, so how do we do that? It's n1 minus 1, so the size, n2 is the west. I think it will be interesting for me if I point. Let's consider Turinga as number 1 and West End as number 2. Okay, well, that's what I'm indicating with the subscripts in the rest of the things. So here we will calculate together. So first we find the pooled variance, then we find, using it, we find the standard deviation for our confidence interval. Here it is. Let me use this guy. So look, these, my computer froze again. Every time I open this little pen, my computer freezes. This guy is here. You can see the squared moves together. It's a squared, so it's the same value. And then from the standard deviation, then we can calculate the difference between the means. So one mean is here, the other mean is here, and we're calculating the difference. All right. And then plus or minus, something we know already, it's the t, but the only small difference, it's still alpha divided by 2, but look at our degrees of freedom. A little bit different. Let's calculate as the addition of our sample minus 2 degrees of freedom. So this is how you calculate. And finally, our standard deviation as we have for the other formulas. So it looks a little bit different, but it's still the mean plus t crit, or is that crit for the other ones. In this case, we only use t crit and standard deviation. Okay, still the same, different way of calculating, but the same formula. So let's go. First, step 1, find the pooled variance. Why is it variance and we have standard deviation? Look, remember, variance is nothing more than the standard deviation squared, right? So you see, we usually call standard deviation S. This is the pooled, and when it's squared, it becomes a variance. Same thing, if you have S squared, square root of this guy, ends up being just the little s, our sample standard deviation, right? But well, in this case, it's the pooled one. So there's a whole way of calculating it. SP, so pool variance squared, pool variance, I mean, it's n1 minus 1 times the standard deviation, this guy, plus the same thing for the other guy, divided by the degrees of freedom, n1 plus n2 minus 2. So I'll click. Look at the values there. I think looking at the values, it becomes a little bit easier. So this is what we get. 55, 32.6, 44 minus 1, 43. Coming from this 44, 16.92. Look, these guys are squared. And what's going on with them? So they used to be standard deviations. By the time we square, it becomes a variance. We squared here, a variance. And then we're multiplying by a number and then dividing by kind of the addition of the number. It's actually, yes, it's the addition of those two. So what we're doing, it looks a massive thing, but we're just getting each standard deviation, transforming to a variance. So square it, it's bigger. And then we just get the weighted average. So if our sample for Taringa was massive, if we had 1,000 observations for it, probably our sample, our pooled variance would be much closer to Taringa than to West End, right? And you might say, no, but this is not neither close to one or the other, because one is 32.6 and the other one is 16.92. What are you talking about being close? Well, remember, this is the variance. So if you get 718.55 and take the square root, we get a 26.8, which is almost 10 more than West End, but less than 6 smaller than Taringa. So almost 10,000 larger than West End and less than 6 smaller than Taringa. Okay, does that make? I hope that is making sense. So this is happening because our sample for Taringa is bigger. All right. I think I spent a lot of time explaining this, trying to get a little bit of the rationale. We're just getting the sample the standard deviation and getting the weighted average. But we do it for the variance. So we square the standard deviation, becomes a variance, and get the weight. The one with the biggest sample size will get more weight than the one with the smaller sample size. And that's it. Let's go. Second step. Finding the standard deviation. So what we're doing here, we will use the value that we had there. Inside of a square root, it will multiply by 1 divided by n1 plus 1 divided by n2. n1 and 2, 55 and 44. So we click that. So pay attention when we're talking about the difference between means. It will not be just a simple take the square root of the pooled variance. There's also this little guy here, kind of dividing the thing, dividing number. Okay, so replacing everything, 718.55, 55 here, 44 there. Then we get during this, get 5.422 as the standard deviation. Now it's the standard deviation of the difference. So it's not close to these guys anymore. This is the standard deviation. This is just the difference. That's why it's considerably smaller. Okay. Step 3, calculate the confidence intervals. I think I forgot to indicate, but we're taking each of these formulas from this slide here from your lectures, right? And then this one's very clear. So step 3, basically the difference, then T, then our standard deviation. Look at that. So the difference is 191.33 minus 172.34. It wouldn't matter if you put the things on the other way around. It doesn't really matter. Look, it would be negative, but it doesn't make it wrong. It just, well, you're comparing West End compared to Taringa, so it would be negative. Here, we're comparing Taringa to West End. So Taringa has a higher mean, therefore, it ends up with a confidence interval on the positive side. Basically, if I rephrase, it's like how much more expensive are Taringa studios, studio apartments than West End. Okay. And then T, we don't have yet, but we know it's a 0.025 because we're talking about, we had the alpha, right, for 95%. And we have this 5.4422. So we're just missing the T. Let's find the T. Let's go. I'll open my chat. Just waiting for your guesses. So T is 0.025 and 97 degrees of freedom. 97 is coming from 54, 55 plus 44 and minus 2. So this is 99 and minus 2. So let's go. 97. Excellent. Very good job, guys. Thank you. So I'll click. And there it is. So we replace it in the formula. And finally, we have the whole confidence interval. I'll put it here. And now we have calculated the confidence interval. It is quite a long process for this one. It's good to practice a few times. Make sure you're on top of it. But the formulas are here. And at this point of the course, it would be wise to prepare your formula sheet. So a paper or a document with a few formulas. And have a look at the slides that I'm adding in the corner of our screen. Because these are important slides made with the formulas. There will be a lot of things, different slides with the same formulas. So yeah, try to filter, just have what you need. But yeah, so the answer here, where difference between the population means. So it's a mu1 minus mu2. It's not the X bar anymore. It's mu because we're looking for the population mean. Okay. And that's the value we find. All right, long process, but let's go. Is there evidence of a difference in the average appraised values? So this is very important for inference statistics. And you see it a lot. When we have these numbers here, and one side is negative and the other side is positive, then there's no evidence for it. We reject that hypothesis that Taringa is more expensive than West End. I'm adding some vocabulary that you don't need to know right now, but we will use in during the last week. So there is, both sides are positive. So there is evidence that mu1 Taringa is larger than mu2. And we can say that with 95% confidence. If both were negative, we could also, there would be evidence that actually mu2 is larger than mu1 if they were negative, right? It's like multiplied by negative here, and you would find that thing. But in this case, that's what we find. So the confidence interval for the difference between the two regions appraised values for studio apartments indicates that value for region 1 Taringa are estimated with 95% confidence to be between $8,230 and $29,750 higher than region 2 West End. That's how we would justify. And let's go to the last item of the last question. It's already 5:18. So also still feel free to jump in and ask something, but I'll kind of go through the assumptions we're making. And if they have been violated, to calculate this one. Also, if you want to stay longer after we finish the tutorial, feel free, and we can talk. But let's go. List the assumptions needed for these calculations. Do you think any of the assumptions have been violated? Let's go one by one. So one, samples are independent is one of the assumptions, one thing that we need to happen. And in this exercise, we will assume since they are taking the values from different regions, we will say that it's not violated since they come from different areas. So it means they're independent. So one doesn't influence the other. Since they are in different areas, we're assuming here in Brisbane, if you're in Brisbane, you know they're in opposite sides of the river, these two suburbs, but we will assume that they are independent. Values are independent. Okay, so this is required because the variance formula has not included a covariance. So the formula we use, since it doesn't have a covariance is when one influences the other. As we're not using it, we're assuming that it's they are independent. The covariance of two independent values is 0. Okay. Let's go. Second assumption. Values for apartments in two samples are normally distributed. And in this case, we don't think it's violated too. Do we know the distributions of studio apartments mean appraised value? We don't. So how can we say it's normally distributed? Our samples are pretty large. It's 55 and 44. And remember that we talked about the central limit theorem, and it said that if n is bigger than 30, we can assume that n, the distribution of the sample mean, is normally distributed. So values for the apartments in the two samples are normally distributed. So not violated, usually required because of using t with a small sample size. But if the samples are large, this assumption is not as important. Okay. And finally, our third assumption, population variances of appraised values in the two regions are the same. And that's what we were treating at the first step 1. It's not violated, required because the sample variances have been pooled, averaged, which only makes sense if they are estimating the same value. So we are estimating the mean of the appraised values of studio apartments, and we did this pooled variance. So this part is not which I mean, sorry, that we're assuming that we're talking about the same thing. So population variances of appraised values of the two regions are the same. And that's it. This was the last item of the last question. This week, we did, at the end of this tutorial, you should be able to determine the sample mean or level of confidence for a specified confidence interval, right? Determine the sample size required and required to provide a specified level of confidence for a confidence interval. And finally, calculate in confidence intervals for the difference between two means, which we've just done. So thank you so much for attending tutorial 8. Good luck with your CMLs, and I'll see you next week.